Graphs of functions. Now I already have covered this lower half of my notes, but not the upper half of my notes, these two pages. So let's cover them all nicely. First is unknown values. For this, we just plug in the value of x without its y value and evaluate it to find out. So, example, here we have some missing pairs. These two are missing pairs, and so if you evaluate this at 3 and at -3, we will get the value that it wants us to find. So putting in the calculator, I will get like so. Very simple. Let's do a few more to get used to it. So we have the function x and l corresponding. So this will be plugging in 18 and 20, we will get the value. We get this. Now here we got 41.5 repeated. What I did was that I rounded it to one decimal place. Why? It's not because I just went with it. No, because it has told me how does the question approximate. It approximates it like this. So I approximated like so. How the question approximates the thingy. Very simple. And you guys get the idea. Let's plug in and fill in the values. Okay, this is for paper 2. For paper 1, it is the same dilemma, but we have simpler functions that we do stuff with. And that oh my god, yeah, I'm not using paper 1 because it just has only one question. Okay, I will be referring to it for the simple case, but it isn't a good practice when you just have only one question for paper 1. I will try to find topicals, but the methods I will tell you for paper 2, they apply the same for paper 1. Remember, you are you are doing the same syllabus in both papers, paper 1 and paper 2. So there's no like a shortcut or a shortcut to I can skip this, I can skip it. No, get up. Let's go and sit in the exam hall with the syllabus prepared. What is there to miss out on if you just a plan to do the entire syllabus? Yes, you aren't gonna get your desired D grade, but come on. Moving on, tangents. How do you draw a tangent and why do we draw a tangent? Now here it's stated for O levels. I think it's for IGCSE. It's also for IGCSE. It's basically just drawing a line. Okay, so yeah, it's the same process for both O levels and IGCSE. I'm just misleading people. One is drawing before we do anything, we need to draw the graph. Okay, we need to draw the graph. And so how do we draw the graph? Well, we plot the values and connect them in a smooth fashion. Now plotting points I explained in coordinate geometry. You must know how to plot points. If you do not know how to plot points, then it's okay. I cannot think of something. Let's plot some points on our curves. So here we have an insanely massive grid and with insanely tiny values. Okay, now lucky thing here is it's already filled. Okay, if it's not filled, of course you have to fill it in yourself and then evaluate like so let's plot it in. X for 0.25 is 4.25 around about here. Now 4.5 it's 2.5. For 0.75 it's 2.08, around like 2 1. Oh my god, I'm doing it wrong. Forgive me. And 1 is 2. Literally, 1 is 2. Next, the 1.25 is 2.05, which is technically the same as 2.1. 1.5 is 2.17, which is 2.2 rounded. So at 1.5, it is 2.2. It's like a bit slow. At 2, at the 1.75, it's 2.3. Damn. And at 2, it is 2.5. Finally, we connect it to, by a smooth, here I'll start from the end. You can start from the top, like about here, but remember, the ends must be the same, like, like here it's like a shooting upwards, so this should be also shooting upwards. I'll just do a bit of cleaning up, like so. Sorry, this was like where? At 4, right? Yeah, around about here. And so I will fix this up. Yeah, like so. You can just do it easily. Okay, repeat and stuff. Now for the points, how I did the points, you let's use a pen to plot the points. Okay, here I'm using a red pen, so that's that, but you will be using a blue pen, so use a blue pen. Now this is drawing curves. Let's practice a bit more of drawing the curves. Plot them with a smooth curve. Now at -3, it is -3.5. Sure. At -2, it is, oh my god, it is 3. At -1, it is 3.5. But before I plot it, I need to plug in my tablet in charge. How are you guys? Fine. Like and subscribe for more. Okay. At -1, we have 3.5. Nice. Done. Very easy. At 0, we have just 1. Boom. Okay, so it's kind of like very steep, very steep. Next is at 1, it will be -1.5. At 1, it will be -1.5. At 2, it will be at -1. And at 3, it will be 5.5. Damn. This crazy. And finally, we plotted.
Thank you, Jay. You sweet. Or real scared, but listen, girl. I'm gonna have to just use your little bed to wipe my feet off, okay? Sorry, girl.
Yes, it's a crime. I did not use my pencil. But you got to somewhat have a smooth curve. Okay. Don't mind this. How about I fix it? Dude, what is going on? Yeah, somewhat like this. Very simple. Like so. It's okay. Like so. Very easy. You want... Okay, I will not do another one. Here, they have not plotted it. They have not given us the lines. Okay, this is the same that you would see in the like new syllabus math Oxford books, where instead of they giving you the plot, they make you plot the plot. Where on a piece of paper, okay, and usually on a piece of paper in the books, but here on a grid next page. Okay, I think they just edited this bit. Draw a horizontal x-axis for 0 to 20 using a scale of 1 cm to represent 2 meters and a vertical L-axis for 0 to n to 60 using a scale of 2 centimeters to represent 10 meters. Now, what is this mumbo jumbo that we just read? For every, so the x is the horizontal. What is horizontal? Horizontal is this way, and vertical is this way. So horizontal, we use x from 0 to 20 by 1 centimeter being 2 meters. So let's go. I do not know where do we start from. So it is from 0 to 20, where each centimeter is 2 meters. So this is 0 to, oh my god, what is that feature anyways? 0 to 4, 6, 8, 10. Okay, 12, 14, 16, 18, 20. Dude, is this even right? I do not even know what is a centimeter. You will skip this. You will skip this. Don't worry. Don't worry. Okay. You do not need to worry about it. They will give it to you. Okay. Like this. Okay. Like a proper functioning human. Why is this? Why did they make you draw it? I think this is old syllabus bullshit. You know. Okay. Skipping this. You know how to graph it, right? Plot and make a smooth curve to the best of our abilities. Okay. So as best as you can. Next we have this resetted. Okay. Yeah. Next we have tangent. For this, we get a ruler and draw a straight line approximate to how steep it is at that point. Next, we sample any 2 points which you can easily see on the graph. Next, we use m is equal to y2 minus y1 x2 minus x1 to get the answer x1 y1 as 0.1 and x2 y2 as 0.2 coordinates. The gradient shows, quote, the range of change of variable on the y-axis with respect to variable on the x-axis. So this is how we draw a tangent. Now before doing so, I will quickly draw some more graphs. Okay, for like examples. Okay, I have drawn a few graphs with to help illustrate this point quite literally. So how do we do tangents? Okay, let's look at the tangent questions. Drawing a tangent, estimate a curve. The gradient of the curve at x is equal to 0.75. Now, if you are IGCSE students, what does do? You evaluate this function at 0.75, the derivative. Let's go. What is this? 1 minus 2 over x squared, go blah. No. You aren't just going to use a derivative and go with it. You need to use the methods taught in this syllabus. So it asks us that x is equal to 0.75. So let's go to x is equal to 0.75 is this point, and we go and look at the point. You already have it plotted, okay, by coincidence, but it won't be, and sometimes you just have to. Now I told you to have your ruler and estimate a good way on how you're gonna make your tangent. So let me whip out my own ruler here. Ta-da! You aren't going to measure anything. You're just going to estimate. Like, how do I want my gradient to look? Does this look good? Nah, I don't like it. I'ma go with this. Okay, it's based on your judgment. Remember, it's based on your judgment. Okay, I'm not gonna tell you Yeah, it should be a little steeper, a little that, a little. No, you aren't going to judge it by yourself. Okay. So here we have a ruler and we estimated this. Now we pick 2 points that we would like and then use that to help us find a gradient. If we do not know how to find a gradient, let's read coordinate geometry, So let's go here and pick this value, and I'm gonna go with this value right here. Now these two are completely random. Okay, it may seem I just chose them at for the sake of myself. No, they are completely random. Okay, you can to base your point that you're gonna choose, find a point which has an easy coordinate. You don't want to spend your entire paper choosing the coordinate or like an easy coordinate. No, let's choose any coordinate. Okay, but it must be such that you can write it in time. So I chose this and this coordinate. Let's see. This is at x is equals to 0.25, and at y is equals to 2.5. This is at coordinate 1.25, and at x and at y coordinate 1.6. Now you find the difference between them. So this is 1.6 minus, no, sorry. Yes, you can have it like this is your first point, your second point. It does not really matter. So I'll do this. 6 minus 2.5 and 1.25 minus 0.25. We get the denominator as 1. As the numerator, we get 0.9, I guess. Yeah, negative 0.9. So this equals negative 0.9 as our tangent. Okay, you got to show your working. Remember, I'm just doing it here because I do not have any space for me. But you got to show your working if you have space. This barely has any space. Okay. But like onto the side, yes you can. But do not write on this margin. Is going to say, limit your space. Here our answer is negative 0.9. Your answer could be different. Remember, your answer could be different. It just depends on how you judge. Okay, the examiner will accept a range of values. Okay, remember, be confident in making the point. Let's do a bit more to get confident. By drawing a tangent, find a gradient of a curve at a point negative 2, 3. Negative 2, 3. So we have already plotted that. So it asks us to find the gradient at that point. So let's make a estimate line of via our ruler. I'm gonna put it right here. Okay, I'm gonna put my ruler right here. It is going past this line. Okay, it may not look like it, but this is, trust me, touching it. So I'll choose 2 points at random. Trust me, it's random. So here it will be this and this point right here. Okay, and so it will be first the y, 4 minus 2, and then the x. At 4 it is negative 1, at 2 it is negative 3. This will give us the value 2, which will give us 1. And so the tangent is 1 at this value. Nice. Very simple. Trust me. Okay. We will I will do this minimum value thingy, don't worry. Let me just do tangents. Drawing a tangent, estimate the gradient of the curve at -3, 5. Okay, this is the last one, and we are moving 3, -5. So just draw it like so. Boom. Here I will pick the points. 4, -2. Trust me, coincidence. I know. 4, -2, and the points at 4 it is -2.5, and at 2 it is -7.5. So this is equals to so this is the top is 2, and -2.5 minus 7.5. This gives us 2 or 5 or 0.4, and that is our answer. Very simple. Let's draw a tangent with your ruler and solve it. Next on our thingy, solving questions which ask you to solve a thingy, to solve the curve. Okay, here's like one this as well. Before that I want to show you this as well, this question as well. It uses functions to represent the curve, the equation itself. Now you aren't going to be like, it looks the same, go convention, go bar. No, it'll use different topics to represent itself. Okay, there's like one question, past papers. Okay, it's not in syllabus. It used matrices to do algebra video. Here it uses curves and gradients to mess you up. Okay, technically, quote, mess you up, but it is very easy. And if I recall, there's this exponential one as well. Okay, which people may find difficult, they may find scary, but no, this isn't scary. How do we solve curves using the graph that we drew? The uses graph, quote, uses graph that we drew. So let f of x be this function, the curve on the function. Given that f of a is equal to b, find f of negative a in terms of b. Now this is a fun question. So why did you plot 1 over x? Okay, it's just doing it again. Okay, I'll just do this question. It looks fun. f of a is equal to negative b. Find f of negative a in terms of b. So if you just plug in negative a instead, negative a minus 1 over a is equals to what b? How is it different? Well, if we know that f of a is equals to b, f of a is what? A plus 1 over a, and this is equals to b. Can we find a plus 1 over a in here? Yes, we can. We can find out that you can factor out the negative, and if we plug in, this is equals to b. We know that. If this is equals to b, we need to make these two the same. So this must be equals to negative b, quite literally. And so we solve the question. Find f of negative a should be negative b, because f of a is normally a plus 1 over a. F of negative a is negative a minus 1 over a. If we somehow figure this out, we find that this is the same as this. If we plug this in again, we find negative b, quite literally. And boom, that is the question itself. I ain't reading a lot, sorry. Okay, you won't be given this much. Okay, it's not like, how many marks is it? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 marks. Okay, sorry, this is a very old past paper. Okay, you aren't going to be, like marks go brr. No, that's really few marks. Okay, it'll be like 5 or 8 marks, don't worry. Okay. So how do we solve the question? Okay, enough yapping. How do you solve it? Well, you are going to first look at this carefully. X cubed minus 2 over all over 2 minus 3x plus 1. You are going to look at the curve that you already made and compare it with this equation. Now here we have this thingy. What is this? This is y is equals to this function is equals to 0. What is on this right hand side? A function as well. This is on f of x and y is equals to 0. If we draw y is equals to 0, we'll find the solutions, you know. So it is basically asking for the roots. So this will be at like around negative 2.6. And next question. Huh? Minus 3x plus 1. Dude, I swear. Either I'm tripping or there's not enough space. Okay, one will be negative 2.6. One will be around 0.4. One will be around 2.3. Nice. Now it will obviously give you like 3 parts. This is the old paper. You guys can do this. Don't worry. No one don't. The line AB intersects the curve at point B. The coordinates of A are A5 and the coordinates of B are T3. Find the equation of the line AB. Not doing a lot. Sorry. The x coordinate of point P is the solution of the equation x cubed all over 2 plus cx plus d is equals to 0. Find C and D. So AB, let's draw AB. So AB is at 0, 5 and B is at 2, negative 3. Now the curve it intersects at this point right here at P. What is this P special about? It is a solution to this question. So how is it a solution to the question? Well, we need to find the curve. Okay, find AB, line AB, sorry. So line AB would be 5, okay, 5 as the gradient and the intercept is this. So 5 gradient, I could just find it with cheating. The gradient would be rise is 2 units and the run is 1 unit, so it will be 1 over 4 technically. Yes, so the gradient is negative 4, so the answer is y is equal to negative 4x plus 5. Okay, negative 4x plus 5. So how do we solve this? Well, we know that these two, that the line and the curve meet at one point. So if they meet at one point, there must be a common ground between them. How do we find this common ground? We just equate the thingies together. Now we need to solve this. Okay, we just need to find C and D. Okay, in the later questions I'll tell you. Okay, here we have it solved. Okay, now we just need to find C and D. Just do algebra, to be honest. Negative 3 plus 4 is x. 1 minus 5 is negative 4 is equal to 0. So it is C is equal to 1, 4 is equals, and D is equal to negative 5, and that is the answer. Okay, now for some actual real stuff. Okay, solve algebraically. Now we have this curve. Okay, we can use our graph to solve this. Okay, use a graph to solve this equation. Now you can do this by yourself Okay, x squared minus 2x minus 10 is equal to 0. But we are not doing a lot. Okay, we're just solving this equation. Remember what I told you earlier. This is also a equation and this is also a equation. If we plot this as well, if we have this already in this on this side, then we can plot this to find the solutions of this equation instead. So if we plot y is equal to 2, you'll find the solutions, them being about like negative 2.2, 4 point, negative 2.2, 4 point. Remember, there are no wrong answers. Okay, it's just that the range will be specified in the marking scheme. Don't worry about it. Okay, do not cry about it. And yeah, solve algebraically this equation: x squared plus x minus 9. We can do this without doing algebraically. Okay, we're not trying to do a lot. We can cheat by using the curve itself. Okay, if I just copy this down here, I'll show you a trick. Okay, it does do it. It's like illegal. Okay, paste. But here's a trick on how to solve this. Okay, if you do not want, here we have this new equation and we want to solve it using the curve that we already have plotted in terms of y. We can solve for this thingy. Remember how we substituted in x in the earlier equation? We do that same here. We find what values were added to this and subtracted from this to get this new equation from this original equation. If we see this is positive x, how do you make it negative 2x? Yes, negative 3x on both sides. So this is x squared minus 2x minus 9 is equal to 0. Is equals to, negative 3x. This is negative 8, this is negative 9. How do we make it same? We add 1 on both sides, of course. And so we will see this is x squared minus 2x minus 8 is equals to negative 3x plus 1. This is the equation. This is also an equation, both in terms of y, and we can solve them easily by plotting this on the curve, like so. This is 3 in 1, so 1 and negative 3 as the gradient. So this is going 1 here, 1 2 3. So the gradient technically looks like so, and so we just extend it here and there. Obviously you will draw it with your pencil. Okay, when you're solving this, always draw with your pencil. Okay, I'm just using a pen for clarity, to make it look beautiful. Okay, to make it look eligible. Okay, but you got to use your pencil. You got to use your pencil. Okay, no clipping me with that you know how you do it with like those podcasting. Okay, now here we can estimate it roughly. This is about negative 3.3, and this point is about 2.5. Negative 3.3, 2.5. Nice. Obviously, this will give you a irrational. If we plug this in a calculator, okay, which some may do, this will give us 2.5413 blah blah blah, and this will give us negative 3.5414 blah blah blah. Yeah, algebraically, but this was to quickly demonstrate how you can solve this. Ooh, The x coordinates of the intersection of the line and the curve are the solutions of the equation. Find equation and line of the L. Ooh, see what I told you? We found the line L even before the question asked us. Now, what line did we draw again? We drew negative 3x plus 1. So the answer is y is equal to negative 3x plus 1. We did not do any rocket science. No, the steps I did here. Okay, that I told you. No, it was illegal. No, we just needed to do them here. Okay, over here you just needed to use quadratic formula. Slap it down, plug in the values, and boom, go on with your day. Because it's paper 2, very easy. Okay, paper 1 people struggle. Why? Because they do not have a calculator, and so cannot do the calculations faster. I remember someone telling me their mind goes blank during paper 2. During paper 1, but they are fully functioning humans at paper any during paper 2. How does that work? Can someone explain it to me in the description? Use a graph to solve f of x is equal to negative 15. So what did I tell you? This is this is y and this is equal to y as well. If we just need to casually draw y is equal to negative 15, and so you will find that it is only one singular value. Disappointing, I know, but come on. Negative 2.4 is the answer to your question. Use a graph to find a such that f of inverse of a is equal to 1.7. Why go for the inverse when you can just use the rule? What is the rule? Remember, f and f inverse of x yield x. The composite of a function and its inverse is always the input itself. So it will return the same value. If this is 969, this will give us the same value, not the scroll and not the color picker, the value itself. Okay, so we use that to our advantage to not have to find 1.7 f of 1 point this value. Okay, well, I will tell you how to do it, but this is alternative way. Okay, so you do f of f on both sides of this equation, and so you do a is equal to f of 1.7, which will be, if we go at x is equal to 1.7 and go up, we will find the value of a. Value of a is this y value, which is like 5 something, 5.1. 5.5. Let's call it 5.5. Now, I think this is a good answer to do it. Good way to do this question. Okay. How do you do this? Never mind. Okay, remember this method. If it tells you to find a value of x or a or the input, such that when taking the inverse of it in the inverse function of that value, you get a result. You are lazy. You do not want to do that. So what do? You do this composite function thing and solve for a instead. You solve for what input satisfies this inequality and is equality and none. Given that f inverse of t is equal to u, express t in terms of u. So this is a bit, so f inverse is we have to find it. So f is x cubed. F inverse is t cube root. Express t in terms of u. So t is equal to u cubed. Remember, we can just do the same thing here. F of f inverse of t is equal to u. So this gives us t is equals to f of u, which equals this value as well. Okay, no need to find inverses and stuff. Okay, as if you find an inverse, blah, do not even take it. Okay, for questions like this, okay, so if we have a equals and an inverse, then just take apply normal function on both sides and your GD. Using the same axis, draw the line that represents the function 5x plus 3. So this is at plus 3 and then gradient is 5. So going 1 and then we go 5 up at 1. So it will go up at this. This is our gradient and we will extend it to both sides. Okay, extend it to the whole graph. Okay, it should not go outside the box, just inside it. So one is drawing it. Okay, good. When you draw stuff, you draw questions, let's mark it with tick. Hence, find the three solutions to the equation f of x is equal to g of x. What does it mean? Find when these two are touching, when these two overlap, when these two intersect. Not touching, please. So one is at this point, one is at this point, one is at this point. This point is at negative 1.9. This point is at negative 0.6. Sorry. And this point is at 2.3. I don't know why I'm laughing. Maths is a serious subject. You should not be laughing. And the last value, boom, like so. Okay. If this video is getting a bit long, like, subscribe and share and keep watching, please. Okay, next I want to show you the last bit of question and you will be done for your life. Okay, and just that you need to remember how to draw the curves, of course. Find a gradient when x is equals to 4. Not doing a lot, chief, not doing a lot. No worries. 2 marks, I can give it to my nephew. Show that the line 2x plus y is equal to 6 together with the graph of this can be used to solve the equation this. Scary. No, it isn't. We know this will be y is equals to negative 2x plus 6 and together with the graph of this can be used to solve this. Meaning we have to equate these two together and solve them and just, rearrange it to get this. Okay, it's like those word problem questions, but instead of x squared it is 2 to the x exponent. So this is 1 over 4 times 2 to the x is equals to negative 2x plus 6. Remember how we did a show me this any, like how if you watch more early, he said show questions are calculation questions but with the answer spoiled. Yeah, this is the same thing. We know that this must have a coefficient of 1, so we multiply 4 on both sides to quickly do this. Okay, so this is 2 to the x is equals to negative 8x plus 24 and we immediately in one step solve it. Very simple. Nice. Hence solve this equation. Now we aren't going to go open up our Discord, find logarithms and boom blah blah blah. No, we just plot this function and go on with our day. Okay, let's plot the function negative 2x plus 6 and boom. So 6 negative 2, yeah, Nice. Okay. And we do this. We find one intersection point, which is this. Blah blah blah. Yes, I know. I'm also getting tired. Okay, it is ending in a few minutes. So this is 2.3, about 2.3. Why does it touch the curve? Why does it touch the curve? The points P and Q are 2, 3 and 5 for respectively. Find the gradient of P and Q. So this is 4 minus 3, 5 minus 2 is equals to 1 third, a third. Nice. Alright, great. Draw the line L. Whose L? Parallel to PQ, and that is the curve this. So we need to draw a line with the gradient 1 over 3, and it should touch the curve this curve. So let's do 1 over 3. At 3 it should be 1, and so it should touch the curve. I'm gonna erase this for clarity, but you must leave in your construction. Okay, if there is a question, draw this curve, draw that curve, draw this curve, you need to leave that curve in, so the examiner can see what judgment you did. Like, I think I might draw this line like so. The examiner can see that your curve looks like this, your line that you drew to solve that equation is this, blah blah blah. Okay, we did draw this, it is touching. Write down the equation of L. Now we know the gradient is 1 over 3x. What is the intercept? Intercept would be 0.2. So the answer is nice. Ooh, another similar question. Back to haunt us, back to back. Yeah, exponential functions are not that scary. You just make it scary by your own belief of not being able to do this because you have not even learned it and expecting a teacher to do everything. I think we need a bit more practice with solving equations using given equations. Now here this is the same. Okay, these two are the same. This is y, this is y, this is already given, so we just need to plot the x intercepts and none. Another thingy, the graph of this coupled with the graph of the straight line L can be used to solve the equation x cubed plus 10x minus 80 is equal to 0 for this and this. Find the equation of L. Draw L. Hence solve the equation. Now first we need to solve for L. Okay, we know this. We need to somehow transform this into this. And let's expand this first. This will be x cubed all over 20 minus x over 2 is equals to some value 0 is equals to 0. Now here we have no 1 as here, so we will multiply 20 and get x cubed minus 10x is equal to 0. Now the only thing missing here is 80, so we do negative 80 is equal to 0. We add 80 on both sides. We subtract 80 on both sides, sorry, and you find this value and boom. Now the equation of line L would be to basically be negative 80. So the equation of line L is negative 80. Why? Because to make these two equal, we basically added negative 80 on both sides. So it will be that. No. Oh my god, I'm so sorry. We need to do the inverse, the reverse. We need to make this be equals to that, and so we can find the equation of that. I'm very sorry. X cubed plus 10x minus 80 is equals to 0. Here we have y is equals to x cubed minus x all over 20 all over 2. Here this is x cubed. Here is x cubed all over 20. Let's do all over 20. This is all over 20. 2, 20. All over 20 will make this become x over 2. And this will make this become negative 4 is equal to 0. Next, the second term. We need this to be negative. This is positive. We do not want this negative u. So we add negative x over 2 to cancel it out, and x over 2 on both sides again to make the x over 2 remain. So we basically subtract x on both sides. So this will become negative, and this will become negative x. Finally, we have no constant value, so we add 4 on both sides. Ooh, we get this thingy. Y is equal to this is equal to this. This is the line of equation of L. Okay, so we draw negative x 4. They do not draw this. Why were they so lazy? So negative 4, negative x plus 4. Nice. So we draw this, and then we basically find the intersections. Okay, like if we did draw this curve, it will be like somewhat of a cubic. The intersection that we have over here will be the solution. Solve the equation this. Yeah, a solution of this question. Yeah, no worries. Use a graph to solve this. Now this is y and this is also y, so simple. This can be used to solve the equation this. Remember how we did the first type of this? This is the same thing over here. So we do x cubed minus 3x minus 1 is equal to 4x plus 3, and we just basically rearrange it to get this value. Okay, on the right hand side we want this x cube. On the left hand side, oh my god, on the right hand side we want to have a and b. So we add 3 on both sides, we get 7. We add 1 on both sides, we get 4, and this is the answer, a and b. What is this?
Yo, this is so weird. Where are you going? Dude, Jason's walking.
I ain't taking English lesson, so use a graph to solve this. Okay, this is another question. So here we have y is equals to this x plus 3 over x minus 3. We know this. We want to solve this. What is the problem? We do not have this on this side of the equation. On the left hand side of the equation, we do not have the value on the curve that we have plotted. So what do? We fix that by giving us our curve back. Okay, like how we fight for our rights. We minus 3 on both sides, we get a curve, and we get a linear in here. Linear as in this, blah blah blah. This is y, this is also y. Draw y is equals to 2, and you will be done for life. Find the equation of. I've already done this type of question. Why is there none of the new syllabus kind of questions? I'm gonna lose it. Dotted line of. Okay, A and B. Okay. So it is, I think, the same thing over here. We basically find A and B. Okay, if we look at it carefully, it is always a linear we solve for, basically. Okay, this is a fun question. X over, say this curve, x over 5, 6x, blah blah blah, this blah 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 is the same, but here we do not have the over 5. What do? We give it over 5. This is equals to 2. And so we plot is equals y equals 2 on this here, and boom, 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 boom. Graph. Okay. There's some, mensuration, geometry going on mixed. Okay, do not be, scared when they mix theory. Okay, for CP, explain. What? Dude, this isn't a physics question, a physics paper. CQ is equal to this, because blah blah blah, we do this, we do that, boom. Shaded area is given by this equation. Dude, how many F? Wow. Okay. I told you I will tell you how to find a minimum value question. These questions ask for the minimum value. What is the minimum value? Minimum value is the lowest y value that the curve hits. Example, we have this curve. Now, here I have plotted the equation in here in Desmos. Yes, I am cheating, but I do not have time. The minimum value is going to be this point here, the lowest value of y. Now here we have plotted this nicely. The lowest value of y is going to depend on what you on how you draw it. Okay, if you draw it perfectly, you may get a estimate 67.777. I swear I did not think of this being a possibility. 67 cameras. Okay, enough anyways. So that is going to be the minimum possible area. Now here we have y is equals to this equation. What is this equation for? This equation for is this. Oh my god. No. Okay, my point being, this equation that we have here is for the shaded region, and y is representing that shaded region. Now as x varies, this region also varies. The value of y is the area. Now it asks us to find the lowest area possible for some value of x. And so here the lowest value of y would be, as we said, approximately 67.7. You might do 67.8 or 68 itself, depending on how you draw it. Remember, depending on how you draw it. Let me find other things to do. Okay, now this minimum has the maximum point PQ. Find the value of P and Q. Remember in the questions I said the vertex is the minimum maximum point in a quadratic function? In a quadratic function, if it is here we can find the value of P and Q very easy. One, we are given the roots. Roots are at -2 and -4. We just do this. Okay, remember, when you solve this, we get x is equal to -2, and so reversing it, you get these two linear factors. Okay, expanding, we get x squared negative 2x minus 8 is equal to 0. Now PQ will be in terms of by solving this using completing the square form. Completing the square, if you complete the square, it will be x squared x minus 2 no, x minus 1 squared minus 9. Yeah, minus 9. So here we have x squared 1 minus 9. I do not like this. Why is this negative 2 but this is 8? Why is this positive 8? What is wrong? Dude, am I bad all of a sudden? 4. This should be negative 8. Why? Dude, this is so weird. This is a 4, this is a 2. This should be x is equal to x plus 2. And it should be x minus 4. So weird. I know. But generally, okay, when we do completing the square, we get something like this. Okay, it will be very easy to integers suspiciously. This, if we flip the sign, okay, this would be the this, and if we flip this sign, it will be this. I'm ending the video here. I hope you understood something. Like, subscribe and share. I'm trying to reach 200 subscribers so I can formally start covering the syllabus with you guys. Okay, because yeah, I have covered some of the syllabus, but I haven't seen anyone besides Cognito. To my knowledge, I've seen Cognito and Ginger Math. They do not properly state they covered chapter 1 fully. Okay, especially the early 4 to 6 chapters. Okay, so that's why if you guys help me reach 200 subscribers, I might start covering the entire syllabus with promising to show you everything that there is to the syllabus. Bye.